Hi all. Sorry I'm not there today. Hopefully these notes will go pretty fast, and as always you can always skip through the video if you feel like you understand something or don't need to see every step of what I do. So the video seems long, but you can of course skip as I'm writing or if you don't need an explanation on something. But before I start talking about this, I just want to remind you, if you didn't see the Google Classroom announcement, we are back in our classroom next week. So on Tuesday, we will be back in A126, so I will see you all then. Okay, so to start this off, I want you to do the warm-up without looking at the screen. So pause this now and then do the 2 warm-up questions and come back. Okay, so in number 1, if you're given the 5, you're also given 0, 4, which is actually the y-intercept, so you could put it in y-intercept form of mx plus b. And number 2, you're given the x-intercept, so you can put that in point slope. So remember, point slope is m times x minus the x-coordinate of a point plus the y-coordinate. But since the y-coordinate is 0, we don't have a number. Okay, so knowing those 2 forms is going to be important for today's notes. So what I would like for you to do now is to look at the next question, and there are 2 different equations, f of x equals 2x minus 5, and that f with this little -1, x equals 1/2 x plus 5. And I want you to write some things down that you notice about the equations. Then I want you to graph them both. If you have different colors, it would be great. Write some things you notice. Fill out a table of values for each. So let's do just -1, 0, 1, and 2 for each one, okay? And you can try and see what happens in that second table. So take a couple minutes, write some things you notice in the top, do the graphs, do the tables, and then come back here. Okay. So, depending on what you put, I hope you noticed a few things. Look at the slopes first. So if you didn't notice this, I hope you saw that with the slopes, one was 2 and one was 1/2. And those do have a relationship between the slopes, 2 and 1/2. So the slopes are reciprocals of each other. Okay. And then I also hope you notice that in the first equation, f of x, you were given the y-intercept to be 0, -5, and then the x-intercept is -5, 0 in the second one. So what truly happened is that those points switched. So the x became the y, and the y became the x in both of those equations. And so these equations do have a relationship. And let's explore that relationship a little bit more in the graphs. So a few things that you might notice about the graphs is that they do intersect at one point if you did the slope the whole way. Okay. The other big thing is realizing what they look like. So it's hard to see if your paper is kind of straight up, but if you turned your paper almost on an angle, they look like they are the same graph. And so if I was actually going to put a line down the middle on that diagonal, they look the exact same on both sides of that line I just drew. And so if you remember, when 2 things are the exact same, they look the exact same off of a line, they are symmetric of each other. So they are symmetric of each other. Because what's really happening is that yellow line is the equation y equals x, and they are reflecting over that line. So these reflect over the line y equals x. So everything that we've noticed thus far is going to be the relationship between these 2 equations specifically, but also a specific type of relationship of any equation. And we'll get there in just a second. But the thing about the points is I did tell you to use -1, 0, 1, and 2 for the x values of f of x. Now this table in the second one for your f with this little -1, I'll label these on my graph, is I didn't tell you which ones to use. You may have noticed this, but if you do see, if the x value is -7, the y value is -1. And if the x value is -5, the y value is 0. If the x value is -3, the y value is 1. And the same thing with this last point. And I'm hoping that even if you didn't see it on your paper, you're starting to now see it. That the x values become the y values in the other equation, and the y values became the x values in the other equation. So what's happening is that these points are being flipped, they're being inverted. So x and y values are switched. So these things you may have not seen on your own, and that's okay, but I'm hoping that you can see them now. And all of these things are going to be true about a special type of relationship between two equations. But these two equations have to be something called inverse functions. So right down here at the bottom, you may not see what I'm talking about, so let me highlight it. On your next page, these types of equations are called inverse functions. They have this relationship between each other that inverses can be between linears. So if you have a linear line, an inverse is another linear line. And hopefully you've heard the word inverse before. Inverse, a lot of the times you hear inverse operations. So if I say, what's the inverse operation of plus, you would say minus. If I say, what's the inverse of multiplication, you would say division. Okay, it's like the backwards. So inverses can be operations, but they can also be functions. So they're like backwards equations. And so every time you have an inverse relationship, you are going to have in two linear functions. The slopes are going to be reciprocals. All of your x and y values are going to switch. Thus your x and y intercepts are switching. The graphs are going to intersect, and they're going to be symmetric of each other over the line y equals x. So we have to keep those patterns and relationships in mind when we try and figure out if two lines are reciprocals of each other or inverses of each other, and how we work with those. So this is a quick introduction to what inverse functions are. And we are starting with linear inverses. So we are now going to try this. So what I want you to do is try on your own first to find the inverse of the equation 3x plus 2 using all of the things that we talked about on the page before, all the relationships. Okay, you could use inverse operations, you could use the inverse graph, you could use the inverse table. There's lots of different ways, but I want you to pause the video now and try to find it using the equation, the table, and the graph. And then you can come back here and I'll explain it in case you're not sure on how to do it. Okay, if you think you got it, you can skip ahead on this video until I show you the answers. If you need a little bit of help, I'll walk you through it now. So if I have the original equation, 3x plus 2, my inverse equation is going to have that little -1, and we're going to say f inverse of x. So it is going to have that little 1 in the notation. Now, we said that all linear functions have an inverse slope that is the reciprocal. So slopes are reciprocals. So if we have the original slope of 3, we know our inverse slope is going to be the reciprocal 1 over 3. 1 over 3. Then we also know that x and y flip. So if we know that the original f of x has the point 0, 2, our new equation is going to have the point 2, 0. So this is why it was important to know how to do both slope-intercept and point-slope form. So I can use the point 2, 0 in my equation. So I would have x minus 2 in my equation, and that would be my inverse function. And I can see that in the table itself too, or the graph, depending on which one you wanted to do first. So if I do my inverse of 3x plus 2, I can graph y-intercept of 2. I'll zoom in here, up 3 over 1, up 3 over 1, continue. Okay, so if I needed to graph the inverse of this, just remember that all x and y points are flipped. So that first point I did was 0, 2. I now need to make it 2, 0. Okay, so you can also kind of do that at the same table. So I know I had 0, 2, so 2, 0. If I find out that x is negative 1, y is negative 1, so that also flips for my f inverse equation. If y is 1, excuse me, if x is 1, 1, 2, 3, 4, 5, y is 5, so it flips and becomes 5, comma 1 for my new equation. 1, 2, 3, 4, 5, 1. And then I can also just keep using my slope. I knew that my slope was 1 over 3, so I could keep going. Or I could keep going by using the table, just inverting the points. Oops, that's not right. I did something wrong. Oh, this point here should be 8. My apologies. Hopefully you guys caught that. You're following along. So you know that these are inverse functions if they also look the same and are reflected of each other on that diagonal line y equals x. Okay. So if you have a few different ways, I know I went through that fast. Hopefully you were able to see why these things have relationships, or how the relationships work, I should say, to find the inverse functions. So you can find the inverse equation, you can find the inverse table, and you can find the inverse graph just by flipping the slopes to be reciprocals and the tables x and y variables. Okay, the last thing is you can also find the inverse function algebraically using that idea of inverse operations that we talked about. So all we have to do is switch the x and y of the original equation, okay, because we know x's and y's flip, but then we have to solve for y. So I'll do the first one, show you in question 5, and then I want you to try question 6. So this f of x is the same thing as saying y, so I know that this is the same exact thing. Okay, so when I'm trying to find the inverse, I know my x's and y's flip, so I'm literally going to flip them in the equation. X equals 1/6, y plus 2 plus 1. Now, this is an equation, but we don't write equations as x equals. We write equations of lines as y equals, and we want to turn it back into function notation. So we do need to turn this back into y equals, so we have to use the inverse operations to solve for y. So the first thing I need to do to get y completely by itself is move my plus 1 over by subtracting 1. So I have x minus 1. Then to get rid of that 1/6, I multiply that by the reciprocal, aka 6 over 1 on both sides. Be careful, it does multiply to the whole thing, so I'm just going to leave it in parentheses. So I'm going to have 6 times x minus 1 equals y plus 2. And then I need to get that 2 to the other side by subtracting, so I'm just going to put it on the end so that it's in point slope form. So 6 times x minus 1, and then I'll put the minus 2 on the end, because now it's in point slope, and I got it to be a y equals. But because this is functions, and a function notation, I do want to use the inverse function notation. So I'm going to turn this back into function notation by doing f inverse of x equals 6 times x minus 1 minus 2. So hopefully, just by at the beginning, you were able to look at the slope. If it was 1/6, your new slope should be the reciprocal 6. Okay, so that's right. And then the point was -2, 1 of the original. And if the original equation had a point of -2, 1, the new inverse equation should have a point 1, -2. The signs don't change when you flip the x and y, they just flip places. So, but that should look correct when you're doing your point slope form. -1, -2. when you put it in point and slope form, remember to switch the version of the x. Excuse me, the sign of the x. Okay, so yes, this was a lot of work to just see the two things that I know about, the slopes being the reciprocal and the points being flipped, to get there. In linear functions, it's much easier just to do the short reciprocal slopes point switch. But you do want to know how to do this algebraically, because sometimes it's hard to figure out what the point is or figure out what the slope is, kind of like in number 6. So I want you to pause this video, try number 6, and then come back to it, and you can see me go through it if you need it. Okay, hopefully you can kind of follow through those steps, even though I didn't talk through them out loud, but you should get, it doesn't matter where the negative sign goes, but you should have at least a negative slope since, a negative equation, because it does still stay a negative slope, but it does become 5x plus 4, all divided by negative 3. So it is a little bit harder to think about, okay, what's the slope? What's the reciprocal then, and then what point switches? So sometimes it's better to do it algebraically. Okay, so if you followed through me on this entire notes, I apologize for how long this video is, but hopefully you were able to skip through some things, so you didn't have to listen to my voice this entire time. But I will write some summary notes just to make sure that you got everything that I needed you to get. Okay, so a function is inverse. This page only talked about linears, but every function pretty much has an inverse function. And we are going to be concentrating on a few different types of inverses. So just general inverse function information. Okay, make sure that you know that the notation for any kind of inverse is f inverse of x. Okay, and every single inverse type, no matter what type of function it is, every input, aka the x value, and output, aka the y value, are switched. Now I say switched, no signs are changed. It may look like that in the linear, just because of point slope form, you have to always make the x value opposite, but no signs are truly changing in the points. Okay, all graphs will reflect over the y equals x line. Okay, and equations will always undo each other. So that's why it's called inverses. So you can use those inverse operations to undo it. And this is going to work for any function. It could be linear, it could be quadratic, it could be cubic, anything. So notations that you'll see sometimes when you see that is that if you have an f(a) of b, when you find the f inverse, the input is now was the output, and the output was the input of the original. So you can just see the a's and b's switches. And then specific to linear functions, if you have two inverse functions, the slopes are reciprocals. Okay, hopefully that made sense. You are going to show your completed notes to the sub so that you can get a copy of the in-class practice. Do some practice questions, turn that in to the sub, and then you can get a copy of your homework. All right, have a great weekend, and I will see you all back in our classroom on Tuesday. Bye.